Hello and welcome to today's SQL Office Hour session. It's always great to be here to help answer your questions about SQL. And what we'll do today is start with something which you've probably all either done at some point or been warned not to do, and that is have a SQL query where you're calling a function in the where clause. And this can really, really slow your queries down. So see why. I'm just going to jump straight into a demo, actually, kick things off and show just how bad this can make things. And I will start this running straight off immediately because it's going to take a while to run, and I'll explain what's happening while it actually executes. So you can see I'm doing a lookup of this table, and I'm calling this inc function while I'm passing in the ID column. What does increment do? Well, as you might guess from the name increment, just increases the value by 1. So what's actually the table definition? Well, the ID is the primary key, and primary keys must be supported by an index, and all the values in them are unique. So you'd expect a query like that, like this, to be nice and super quick. But applying the function to it has really slowed things down. And alas, it's finished, and it took just over 40 seconds to get one row. So merely adding that function to this query has made a drastic impact on SQL performance, because we're looking, instead of looking up by primary key, just doing a nice fast index lookup. That if we get the plan for this query, we can see we're doing a full table scan. So there's several problems that calling functions in the where clause or passing columns to functions in the where clause can do. First, perhaps most importantly, is it tends to disable index access, or limits the optimizer's ability to use indices, and you generally fall back to a full table scan and really slow things down on large tables. Next kind of problem here is we're doing lookup essentially by primary key, so we expect just one row, but the optimizer's cardinality, its estimate for how many rows we're going to get, is way out. It's estimating, let's say 1, 2, 3, 4, 5, 100,000 rows, and we're getting just one. That is a colossal error, which is likely to lead to suboptimal plans elsewhere in the query. And finally, of course, just executing the function itself is going to take some time, right? So for these reasons, people tend to very strongly urge you not to use functions in where clauses. So we're going to look at kind of why this is, what you can do about it, and alternatives if you actually have to do this. So one solution is generally just rearrange this. If we can see, if we can, instead of passing it to the function, we just decrement the value we're searching for, and we'll execute this query, and bang, bang, straight away, well under a second it took to execute it. And if I get the plan for that, you'll see, again, we get the index access back. So as much as possible, we want to try and avoid calling functions in a where clause. But as I said, it's not always going to be possible to do that. So in those scenarios, we'll look at things we can do to kind of help work around this. So let's just jump back, and we'll look at this in more detail. So hi, everyone. I'm Chris Saxon. I'm part of Gerald Benzel's developer advocate team. It's my job to help you get the best out of Oracle database, and hopefully have a little bit of fun whilst doing so. So with that in mind, it's great to be here for these office hours sessions, and we're going to be looking at optimizing calling functions in the where clause, what we can do about it, and why this is such a problem. Okay, so the first and probably biggest problem that using these functions causes is, as I said, it limits the optimizer's ability to use indices. So at this point, we might be wondering, why is this? Why does this prevent the optimizer from searching the index? Why does it use a full table scan instead of searching what we've got? Well, let's just stick with my silly little example we had before, where I was just incrementing things on the primary key. The index behind that is almost certainly a unique index on the ID. And that index will store the values for those columns and the row ID pointers to them. So in our index blocks, we've got information like this. We've got all the primary key values, 1, 2, 3, 4, 5, up to however many values there are in the table. Now, the problem is we're storing the kind of raw values, what they are in the column itself. And any function you supply is essentially a black box to the database and the optimizer. In order to know what the output of it is, it actually has to execute it. So what this means is even something fairly simple, like just adding 1 to the column, it'll have to go and search through all these entries in the index. So at a minimum, it kind of has to scan through every single entry in the index, has to full scan that index, applying that function, and then probably visiting the table for a good chunk of those as well. Worst case, it'll end up full scanning through the whole index and full scanning through the whole table as well. So potentially there is a lot of work that could be done here, because it's possible that you have a where clause which doesn't actually do any filtering. It just returns all the data from the table. And the key point here is the optimizer just doesn't know, or the database doesn't know, what the output of it is. It doesn't know the result. It has to actually execute it. It has to apply it to the values to figure out what's going on and then run the query as appropriate. So now, so this disables indexes, and typically it'll end up full scanning the table rather than using any available. So at this point, some people are going to go, well, we had a fairly simple query in this, or simple function in this case. All we were doing was adding 1 to the value. And a lot of people think, well, that's pretty simple. That's it's elementary maths. It's one of the first things we learn when we're counting and doing arithmetic. You just add 1 and you get the next value. And in order we could do the opposite of that. The opposite of adding 1 is subtracting 1. So a lot of people think, well, we've got this function here. We're just adding 1 to a column. Surely the optimizer could just rearrange it like this, subtract the value from both sides and turn it into this. So in effect, we've just got the column on one side, and then whatever our search value is minus our function or the value that we're searching for. Seems pretty straightforward, right? Seems pretty simple. Why can't it do this? Well, first, and of course, it's always possible to add these things, but the fact is, as things stand today, it just hasn't been implemented. Why is this? Well, there's actually quite a lot of complexity involved with doing this kind of rearrangement. Even something fairly simple like just turning addition into subtraction, just swapping it around, or vice versa, subtraction into addition, adds an awful lot of complexity to what the optimizer is doing. First up, we need to think about what this value actually is here. So in my simple little demo, I was just adding 1. So we would do subtract 1. But let's think a bit more general case about any query that we might submit where we're adding values together. Well, what is that value? It could be a constant. It could be a Boolean variable. It could itself be a function, right? It could be, we could be subtracting a function. It could be a column. We could have one column subtracted from another. It could be a column passed to a function, and so on. And it could be all sorts of combinations of these. And certainly if we've got columns on both sides of the comparison, very likely, if you think in terms of joins, you're joining tables together on their columns, and you've got a function on one side, does actually moving that expression to the other side, does that make things better? Does it make it faster? Don't know. We'll have to come up with some kind of costing model to analyze that and figure out whether that really improves things and makes things better. So even something fairly simple, just rearranging addition and subtraction, already brings in quite a lot of complexity. And that just gets worse and worse as we look at other mathematical operations. We think like multiplication and division. So they are the inverse, the opposite of each other. But of course, if you're multiplying a column by some value, you can't necessarily just then divide that through by both sides. Why? Well, you could end up with divide by 0 errors, right? So queries could start throwing exceptions where they were impossible before. So rearrangement, while theoretically possible, may not always be practically possible, because it could give different results. The other thing to bear in mind here is that the optimizer, it's already got a hard job, right? It's got to very quickly come up with whatever it thinks is the best way to access these tables, how to join them, which indexes to use, and that kind of thing. you only need something like 5 tables in the plan, and already you've got tens of thousands of possible join orders, join operations, how you combine them. You increase that up to something like 10 tables, and you're well into the millions, way beyond the millions. Each new table you add to the query, to your joins, exponentially increases the number of possible ways you can join those tables and combine them. So you very quickly reach a point where the number of possible ways you could join and combine those tables it's impossible to compute. There is no way to actually compute that in a reasonable amount of time. So the optimizer already has a complex job. And even something relatively simple, like just taking an addition and turning it into subtraction or vice versa, already at least doubles the complexity of the work it's got to do, right? So we want to kind of limit that. We want to limit the number of things that that is able to do. And certainly for something simple like this, you might go, well, if it's that easy, why can't the developer or the programmer do this? Why do we have to rely on the optimizer? We want it to do the hard job of figuring out how to join and combine tables, not the relatively easy things of rearranging some simple formulas. So even something relatively basic like addition and subtraction already opens up a whole can of worms and a lot of complexity, and potentially can make the process of optimizing parsing queries substantially slower. So we've decided just not to do that, right? It's not worth the effort that and the benefit it brings. So we go, okay, that's great. You said, well, why not just rearrange the function? So we do this rearrangement for us. And it's like, well, yes, I'd like to, but maybe you can't change the code. Now, there's a lot of reasons why this might be, some good, some bad. Maybe it's not your application. Maybe it's a third-party app. Maybe you just got really bad processes where you work and it's really slow to actually get code changes out. Or maybe these functions have just been used throughout the code and it's just going to be a huge amount of work to go through and change all the queries that use them. So there are some cases where you're kind of stuck with having a function in your where clause for one reason or the other. So how can we help the optimizer use an index in these scenarios? Well, the solution's fairly simple, and that is we make a function-based index. So the function you've got in your where clause, you then put directly into the create index statement. So here we're just kind of adding one. So what this means is now that the optimizer stores the result of that expression. So now when searching the index, it can go, what's ID plus 1? And we know the output of that because we pre-computed it. We've evaluated it, stored the result, and we can search that effectively. So at this point, I'm just going to jump back to another demo and kind of walk through some examples of going through this. Before we do that, I just saw a couple of comments. How about using, I'm not sure what you're referring to there, with X as select star from Y, select star X from where. I'm not sure what you're getting at there by saying that. If you could explain in a bit more detail, that would be good. Someone just put their hand up for a second. Did they want to say something or ask something? No. Using a subquery. So using, we can talk about that a little bit more later on, but just using a subquery on its own isn't really going to solve a lot of these problems. I mean, in particular, if I've got this function inc on unique values, I've still got to compute it for every single row, right? And just sticking that in a subquery isn't going to change that. It's not going to change the optimizer's computation around it. There is a scenario where it can help, but it's very specific. And if we've got time, we can cover it later. Okay. So let's go to the demo. Now, this example I had of just adding one was kind of a bit dumb, really. It was just kind of really to prove a point and show you how bad things potentially could be in a fairly simple way. Let's look at a slightly more realistic one. So I've got this function, I've got this query, I've got a index on this transaction date, and you see it's nice and fast. We can see it is in fact, using the index. Now, the problem with this is that in Oracle database, the data type always includes the time, right? So by doing this, I'm only finding the rows that were inserted at exactly midnight today. What if I want to find all the rows that were inserted today, anytime today? Well, we need to then search across the range. And classic thing I've seen a lot of people do this is use trunc. So trunc effectively strips the time component off, just sets it down to 0 midnight for the time for that day. So this effectively then allows us to find all the rows that have an insert date or transaction date of today. Problem here is we've now got our full scan, because this we have to compute this function for each row, and we don't know what the result's going to be. So we've stopped the optimizer from using this index here. Now, remember I was saying earlier that we would then have to kind of full scan the index at a minimum. There is kind of a little, I'm not sure loophole's the correct word, but there is a scenario where we could just full scan the index rather than full scanning the table. And that's when the query only accesses columns in the index. So if I just reference transaction dates, for example, we'll see we've got a fast full scan of the index. So in some scenarios, we can use the index even though there's a function on it, but we're still full scanning it rather than range scanning it. We're just getting a small subset of the data, but we're not. So we would like to use an index to look that up efficiently, but we're still having to scan the whole thing. So what can we do about this? Now, just a general point. I've got a whole bunch of indexes I've kind of pre-created in advance because they take 30 odd seconds to create, and sitting around and watching an index create is, let's say, not the most exciting thing in the world, right? I certainly don't want to sit here watching it. You probably don't want to watch it either. So I pre-created a whole bunch of indexes but made them invisible. What this means is the optimizer can't use them by default. It maintains them, so as we insert, update, delete the data, the index stays in sync with the table, but by default, the database isn't actually able to use it. In order to use it, we have to twiddle some session settings or make them visible. Just as a side note, if you're interested, automatic indexing, which came in 19C in Oracle database, as part of the validation process for deciding, validating these indexes I think are useful, are they actually useful, uses this principle. It creates invisible indexes so it can test them out without making them generally available, and then make them visible when it's decided that, yep, they do in fact improve the performance of queries. Anyway, I have created my function-based index on the trunk of the transaction date, made it visible, and now if I run my query again, this time, takes a second or two, but not too much time, we see it does in fact use this index, this transaction date index. So problem solved, right? Let's just create function-based indexes that match our where clause, right? Why don't we just do that? Well, you could, right? You could do this, but it's still preferable to just create the plain, index just on the column. Why? Well, think about what if we want to search for a different kind of granularity. This finds all the rows on a particular day. What if I want to find all the rows with the transaction date of the current hour? Okay, so I can use trunc to do this. We can pass in different format masks to trunc it to different times. So this trunks it to the latest hour. Problem is, we've now changed the function slightly. So it no longer matches what's in the index. And so the database falls back to doing a full table scan, right? Because that information is not in the index. So one of the challenges with creating function-based indexes is that you tend to limit reuse. If you're not using them in exactly as a general rule, you have to use them in exactly the same way, exactly the same arguments. There are some scenarios where that's relaxed slightly, but it's useful to think of it as it has to be an exact match. And if we ever want to tweak that requirement slightly, either we'll fall back to a full table scan, or we have to create another function-based index. So what should we do instead? Well, for something like this, finding all the rows on a given day, we can just rearrange the formula. Say that everything that's greater than or equal to the start of today and strictly less than tomorrow. And we run this query, and it'll take a second or so. We'll find it uses date I. It's that original index that I had before. So we didn't need to have our function here. We could just rearrange the formula ourselves, and it would do this. And the great thing is about this compared to that function-based trunk index, what if we want to search for a different time frame, the current hour rather than the current day? Well, we can just change what we're searching for, our start and end dates, but we can still, the optimizer can still use that index, that plain index on just the column, and that will execute nice and quickly because we're fetching even less data here. So while you can create function-based indexes, it does limit the optimizer's reuse of those indexes. It's much better to try and rearrange the formula yourself. So questions or comments on that before we move on? And we could create DBMS stats, create extended stats, and then DBMS stats, gather stats. You could do that to kind of help the optimizer know what's going on here. That doesn't solve this kind of fundamental problem of these values. If we go back up to trunk of this, those values are not stored in the index. And as I said, as a general rule, it's still going to have to walk through all the values in the index, all the entries in the index to apply that function to know what's actually going on here. So creating extended stats can help. It can help this cardinality estimate. It can help it figure out how many rows it's going to get. But that in itself is not going to solve the problem of us having to full scan either the table or, if we meet some criteria, the index itself. So it's a good idea and it's worth doing in some places, but it doesn't solve all the problems. So another question, will it use the index for between in this case? Yes, it can. So you mean if I just rearrange this? So instead of doing between, I do index between and so I think it's actually a good point you make and something that's worth touching on. So if we go to between, you'll see it's doing the range scan. I mean, at this point, because, or are you referring to the trunk index? Which index are you referring to? While you're answering that, I'll just cover this in a little bit. Because I see one thing I see a lot of people, I see fairly frequently people do is do something like this. They'll say between the start of today and the end of the day or the next day +1 minus 1 second. So there's 86,400 seconds in a day. Subtract that off. This can work, but it does rely on the fact that this is a date type granular to the second. If we decide we want to change this to a timestamp, which has fractional seconds, this logic falls apart here. Really, if you're doing range comparisons, I always forget whether it's closed open. I think it's closed open. But this is the right way to do these things. Greater than or equal to the lower bound and strictly less than the upper bound, because it avoids problem boundary conditions where you've got the incorrect granularity and then for either exclude or include rows that you shouldn't have done. Okay. So there's a few people making some points which I'm going to come back to later on. So got it uses regular index as opposed to function-based index. So not understanding the difference between trunk column equals trunk sys8 and right. Okay, so I think you've got that as I was talking away. You've got it explained different there. So someone else is putting there. Are people intending to put their hands up? If you are, that's fine. Just put your questions in the Q&A or and I'll address them. Otherwise. Okay, so it's good to have lots of questions. It's great when you get involved and kind of interact. If you are still typing away, don't worry about it. I'll be breaking at various other points to capture on this. So let's just recap what we kind of covered there. So as I said, if you've got a where clause and you are applying expressions to columns, table columns, then you are then forcing the optimizer down full scans. Normally that will be a full table scan. If you're lucky, in some cases that might be a full index scan. But you are the key point here is the values you are searching for are not stored in the index. So essentially it has to walk through all the values to know what's going on here. So you're full scanning things. So how can we address these things? The absolute best way is really to rearrange the formula. So as we saw with addition and subtraction, you can manually manipulate those, or more kind of more commonly or more regular requirement is finding things within a date range, and then use that greater than or equal to the start date, strictly less than the end date rearrangement, rather than trying to use a trunk function-based index. That said, there might be situations where you can't rearrange. Now, this could be, as I said, because you're not able to change the code and so on, but there are some cases where you just cannot rearrange the function at all. And in those scenarios, what you want to do is use that expression in the where clause and use an identical expression in the create index statement. As a general rule, as I said, you want them to be identical, the same. There are some situations where they don't need to match perfectly, but as a guiding principle that's really useful to think of. It's better to make sure that they match and then be in the happy world rather than hope that they match and then the optimizer can derive one from the other. And then if it doesn't work out, be stuck with a full table scan. So if you must have a function in your where clause, then we can create a function-based index. So, and as I said, there's good reasons and bad for that. Bad reason is you've got slow processes and you're not able to change your code quickly enough for whatever reason. But as I kind of was alluding to, it is possible you've got formulas which either you cannot rearrange or it's just not safe to rearrange. As I said, addition and subtraction, we can swap those around. But let's think about multiplication and division. The optimizer can't just, or in general, we can't just take a multiplication and turn it into a division because we might end up with divide by zero errors. You need extra checking to make sure that your query is not going to start throwing errors when it didn't before. So there are scenarios when you have to use that function. And we said one way around this was to create our function-based index to store those values so we know what the output of the function is. Another way we could pre-compute that information is we could do it ourselves, right? We could, every time you insert or update a row, you could then format the data appropriately. And what does that mean? Well, what that typically means is then you would create some triggers on the table. So before insert or update and do the conversion that you need. Now, here in this example, what I'm doing is kind of like using trunk to store the dates without a time. So they've all got a time of midnight. Okay, we could do this, but the big problem here is we are now losing information, right? I mean, maybe if I've got a table where the date values are calendar dates, they should have no time on them, this is okay. But generally speaking, we don't want to lose information like this. It's just not going to be acceptable. You need that time component because you want to know when exactly a thing happened, right? So this could work in some scenarios, but generally speaking, we wouldn't want to do this. So an alternative to formatting it directly into the column itself is actually to essentially duplicate the information. We could create two columns, one with the raw data and one with the formatted data. So we can store that on the way in. And this could work, right? We could be able to do this so that every time we insert an update, we store the raw data and the formatted data and any other derived information that we want to get from this. Any of you who've worked with data warehouses have almost certainly seen this in the form of a time dimension table, where you've got a row for each day, and it's got the date plus a whole bunch of derived values from that date. You know, what the day of the month is, what the month is, the year, the fiscal year, the quarter, the fiscal quarter, that kind of thing. So there's a whole bunch of derived values, and they are pre-computed and stored in the table, and we can then use those. And this tends to work pretty well on things like data warehouses, because they're generally insert only, so the data is fairly static. Certainly something like a time dimension, we could populate that now. I could run a script now that would populate it as far back as we need to go, and as far in the future as we need to go, and then that's it. It's done. Maybe every now and again we might need to add some extra columns or tweak some of the values because we made a mistake or something. But those values are fairly static. So in situations where you're going to write the data once, and that's it, it's basically not going to change, and we're okay with doubling up on that information, we could be all right. But if we think things like people's names, like customer names, they are more likely to actually change here, right? They could change any time. We don't know when, could change frequently. We then got this overhead of doing the computation on insert or update. Means we probably need a trigger to do that, or a check constraint to validate that they stay in sync. So we need extra work to make sure they stay synchronized and don't get out of sync. But also we're doubling up the information we need to store here. We've got the raw data and the formatted data, which means we're storing more information. And at this point, there's always someone who's like, well, disk is cheap, who cares? We'll just throw all the information and store it. And, that's true. Disk is pretty cheap these days. Cost per terabyte is generally fairly small. But, last time I checked, businesses always prefer to spend less money rather than more. So if you can find simple ways to save costs, it's generally a good idea. Now, that said, when it comes to disk, the savings are generally going to be pretty minor unless you're truly colossal amounts of information you're storing. But also this focusing on the dollar cost or the pound cost of buying those disks kind of misses the point as well. If we're storing more information, that means we're doing more work every time we read that information. If we have to full scan that table, we're having to read a bunch more data, which means the database has got to use more resources to process it, throwing more information around the network, and so on. So while, okay, disk is cheap, yes, we're increasing our costs throughout the processing stack, just processing more information, throwing more stuff around. We need more capacity on the network. We need more memory on our machines to actually cache that information, and so on and so forth. So generally, it's better to reduce the amount of things that we're storing. So this pre-calculation can work in some scenarios, but yeah, I wouldn't, only in some specific ones. Generally, you don't really want to do this. So in those cases, you might be better off just creating a function-based index, right? And you go, okay, we'll do that. We'll create our function-based index on the trunk of the transaction date, and we can drop or recreate that as necessary, more easily at least than adding columns to the table, right? So all great, right? We've decided we're going to create our function-based index on trunk of the transaction date. All good. Well, yeah, all right. But there's one thing that I learned is like developers are pretty inventive, right? If you ask 3 developers to do a task, there's a good chance you'll end up with at least 4 different solutions. Everyone's got their own way of doing something, and someone always changes their mind partway through because they realize there's a better way of doing something. So we can use this trunk approach to kind of strip the time component out, but there are other ways to achieve the same goal. For example, someone might decide instead to use toChar, do the toChar with a format mask that excludes the time, and then search based on that. It's like, achieves the same goal here, really, searching for all the values without the time, find all the values in a particular day. And, and the problem with doing this is it cannot use that index that we created previously. Not only is it completely different function. They're returning different data types. One returns a date, one returns a string, and so on. So just because we've created a function-based index, and just because someone else is doing the same thing, doesn't mean necessarily that they're actually going to use that function-based index, right? You can just like, God dang it. Everyone's got their own pet approach to doing this, and they've all created their own function-based indexes to support this, and lovely. And it all can potentially end up in a bit of a mess, right? So if you are creating function-based indexes, what can you do to limit this, to make, increase the chances that people will reuse what's already there rather than try and build their own homegrown solution? Now, there's kind of two parts to this. One is a big part, which is way outside the scope of what we're going to talk about today, and that's things like, code reviews, coding standards, other kind of process stuff, which, you should have in place to catch these kind of problems or differences of opinion when they arise. But as I said, that's not what we're going to talk about today. We're going to talk about practical things you can do in the database to reduce this chance people are solving the same problem in two completely different ways, essentially. And one way to do that is to create virtual columns. So what these do is they store the results. Let's say they store an expression, and they literally just store the formula itself. And we can then create an index on that virtual column, and we can access it just like a regular column as well. You might go, well, why do this? What does this give us that a function-based index doesn't? Well, the key thing here is this virtual column is in the table. And as long as you've given it a meaningful name, right, then it's fairly obvious what it is, it's more likely that people will reuse that rather than try and grow their own thing. Doesn't mean, of course, that it's impossible. People may not be paying attention. They might have tight deadlines. They might be in a rush for whatever reason, not be able to not pick up on this. But by defining our virtual columns with meaningful names, it increases the likelihood that someone will reuse what's there rather than trying to build a new solution. And I see this is a comment about, in the case of, pre-formatting the data, the application has to be aware of the new column and use it in queries. Absolutely, right? If you are going to do that pre-computing solution, then people need to know it and understand what's going on. And it's kind of the same thing I'm talking about here, really. You need process outside the context of what we got to talk about today to address that and make sure people are doing it the right way. But as I say, as long as you give columns meaningful, relevant names, and perhaps maybe as well add some column comments to them too, so it's even more clear what's going on, you just increase the chance that people will discover what they're supposed to do without having to go through extensive reviews to find it out. So at this point, I'm going to jump back to a demo and show walk through another example where this will be necessary. So, so before we're doing date formats. This time, let's look at names. And we can see, actually, I've got names in 3 different case. We've got uppercase, lowercase, and init cap, or initialized capitalization. And I've got an index on this customer name, and we see the query does, in fact, use this. So this works for some notion of works, right? Because I need to know what all the possible combinations of case there are, right? Thing with text is people can enter text in all sorts of formats here, and we might need to have like mixed case search as well, just in case. So this assumes that people are entering names in one of these 3 formats. As we'll see in a minute, that's maybe not always the case. So this works as long as we can guarantee what they are. More generally, if we want case-insensitive search, what it's better to use is use the collate keyword. So this is something we added in 12.2, and we can use different types of case-insensitive or accent-insensitive searching as well. So here I'm just saying binary CI, case-insensitive search. And this does a case-insensitive search of the thing, and we'll see we'll get it back in different cases. But it's doing a full table scan here, right? we are applying a function to this column to do the case insensitivity. And you went, okay, all right, well, why don't we just rearrange this? And you said best thing to do in these scenarios, rearrange it. So let's just take this collation and stick it on the other side, right? So let's do that. Let's rearrange it. It's like, hang on, we've still got a full table scan here. Why haven't you picked up the index? I've rearranged the formula like you told us to. Well, if we expand these filter predicates, you'll see it's not quite so straightforward as just a basic rearrange. We've got this collate keyword is actually kind of nice little syntax for NLS sort. So the database is still applying a function to this column. We just kind of hidden that fact. It's not immediately apparent by actually doing this. And as I said, there's lots of scenarios where functions don't actually have a direct opposite, or it's unsafe to rearrange it. And here's one example. Here's an example of this. Case-insensitive searching of text is, a very common requirement, and you'll almost certainly want to do something like this at some point. So why don't we normalize all the values to common case? So we've got, as I said, we could just uppercase everything on the way in. And that way it's a standard case, and whatever value we're searching for, we can just uppercase that. And then we could use an index on this column here. So we could do this, but as was mentioned, the problem here is we need to know this query, this column exists. We've got to do it use it in our application. Everyone's got to be aware of it. Hopefully they'll spot it, but who knows? The other option is we could just ditch this original customer name here, this raw unformatted value. And yeah, okay, you might get away with that in some scenarios, but names don't necessarily follow easy case rules, uppercase, lowercase, init cap, that kind of thing. You think about my colleague, Connor McDonald, who's got the capital D in the middle of his, partway through his surname. Often with things like names, case actually matters. We can't just throw away the case and then get things back in the correct format or in an easy way. And people tend to get really upset when their names are spelt incorrectly, formatted wrong, that kind of thing. So, in some cases, maybe we could just uppercase all values, all names on the way in and just have a single column for it. But quite often you will need to store those raw values, the unformatted values, and let the end users actually format the name as they want it to be, right? So, that gives a dilemma. What do we do here? Do we double up? Do we create a function-based index, and so on? So what I'm going to do here is create our function-based index using the collation. As I said, I've used the invisible trick to save us having to sit and actually watch me create the index, make it visible. And now if I run this query, we will see it does use this index, which I've just made available. So this now allows case-insensitive searching here. We can see we've got it, and we've got the different cases for my names. All great, right? All done. We've created our function-based indexes. Don't need to worry about it anymore. Well, as I said, there's more than one way to solve a problem. What if someone is not familiar with the collate keyword or decided not to use it and stuck with lower? They've just lowercased everything. It's another approach you could take to doing case-insensitive search. Well, back to the full table scan, because the result of this function is not included in this function-based index. Okay. All right. So how do we increase the chances of people using our function-based index? Well, I'm going to stick with lower this time. I'll stick with lower. We could create our virtual column, and we're storing the expression. Now, this is, when I say, the thing I'm doing the quotes here, literally it just holds this as the default value for the column. It doesn't actually store the result of this function. It is always computed at runtime. Okay, so we get that as we fetch it from the table. However, we could create an index on the virtual column, and we're then storing or pre-computing result of that. So again, here's one I made earlier. Let's just make the virtual column visible and the index itself visible. So now we can use that virtual column, and hopefully, because we've given it a meaningful-ish name, people will pick this up and are less likely to then go ahead and roll their own or craft their own solution here. All right, hopefully. Okay, so but what if they don't? Well, the nice thing about this virtual column-based approach is if someone doesn't spot this column and decides to use the function itself directly in the query, the optimizer can still actually pick up this function-based index. Just prove that we've got it actually accessing values from the index itself. Okay, so okay, so you might go, if someone is doing this, they might go, why don't I just create a function-based index on that? Let's see. It's like, yeah, virtual column already exists for this expression. It's like, what's going on here? What's the issue? Well, if we look at the columns in the table, we can see there is this data default here. And there's my virtual column I just created, but there's a whole bunch of these sys columns. I was like, what are they? Well, function-based or virtual columns plus an index are really just the exposed mechanism for function-based indexes. We create a column with the expression, trunk sys state, and then index that virtual column. So we could use these directly. We could do this. We could use the hidden columns that the database has created for us, but I don't know. It doesn't make much sense to me. It's a hidden column, so it won't appear in select stars by default. It's literally no idea what this means. Database has just generated it for us. Yeah, so it's much better to create the virtual columns if you want to. Okay, questions, comments on that before we move on? Nope, I'm not seeing anything else on that at the moment. All right, so let's just recap that quickly. What about defining the column with collate? Yes, you can use column-based collate. You can actually push the definition to the column itself, column-based collation. That is another solution as well. That's specific to collate. I'm trying to think just more generally to things that you might do for any function. As we saw, there are some functions that are necessary. You still have to use them. This could be because they are one-way functions. There is no direct opposite. They have no inverse. Modulus is a good example of this. There's no inverse and modulus. You can't go back to the original values. Or even there is an inverse, but it's unsafe. Think divide by zero type problems. So in those scenarios, we're essentially forced to use a function. So how can we mitigate the impacts of that? Well, one is to pre-calculate values, actually create a new column or format it onto the original column. As I said, formatting it into the column itself means we're losing information. Might be acceptable in some cases, probably not acceptable in most. We could double up, have the raw and the formatted values. Again, doubling information, got to make sure they stay in sync. People need to make sure they use the right column. Can work in some scenarios, but a lot of situations, it's just going to add a lot of extra overhead. So in those cases where you've got necessary functions, yes, you can create the function-based index. I think it's better to create a virtual column and index that. The optimizer will still, if you use the raw function on its own, the optimizer can still pick that up, but you just increase the discoverability, like I said, the chances that people will do the right thing and not invent their own solution. Okay, let's move on. And there's one final thing I'm going to cover here, and that is PL/SQL. So in the original thing, I had my noddy +1 increment function, which was inside PL/SQL. And it might be that you actually need to, you're doing something complicated in PL/SQL, so you want to use that in your where clause. You might go, okay, we're forced down this route for whatever reason. Let's try and create an index it. Whatever happens, we get an error. The function is not deterministic. So if you want to create function-based indexes on your PL/SQL functions, you must declare them as deterministic. Given the same input, you are going to get the same outputs. This can also help the optimizer spot potentially other optimizations as well when actually executing this. But we absolutely have to do this when creating the index, otherwise it just won't do it. All right, okay, so that's nice, but what about the scenarios where an index doesn't help? So there's a few cases where this may be. One is non-deterministic functions, ones that can change every time. Think anything that's based off sysstate, right? Like the age of a row or something like that. If the output can change each time, given the same inputs, we just cannot index it. Another thing is you might want to pass parameters to it at runtime, okay? So use information that's not stored in the table to do the calculation. So there are some scenarios where we just need our function and we can't index it. So what can we do here to help improve performance? Well, one thing to note is that the SQL and PL/SQL engines, they have separate runtime engines. Every time a SQL calls PL/SQL or vice versa, there is a switch backwards and forwards between them. So it's called context switching. One thing we can do to reduce the cost of that, the overhead of that, is if you got a function that you know you will primarily be calling in SQL, you can use this PRAGMA UDF, user-defined function, which lowers that overhead and can speed up your queries. So that's something that can help here. Another thing, the newest feature on the block in 21C, Scalar macros. So what happens is, with these return an expression, the text of an expression. The database resolves it at parse time. So at runtime, the PL/SQL function is gone. You are down to just whatever that underlying expression actually is. That becomes part of your SQL statement. Let's just look at how those actually work. So let's look at an example where we can't index it because we're doing currency conversion. We'll see why in a minute. So I've declared it deterministic, so we can index it, and I'm dividing the X rate through, okay? Which means that I need a zero check, so we don't get divide by zero errors. And you notice I'm not just doing a straightforward round, I'm doing some funny business so the business can optimize how it's actually doing here. So the thing to note with this is currency conversion, it's likely we're going to use this a lot in the application. And it's financial data. You almost certainly want it to be done in exactly the same way throughout your app. You know, particularly this formula we've got here. You don't want people rounding when they should be using the floor or something like that, or the ceiling. So we're kind of forced down the route of using this function. And we could create a function-based index on it. You know, we've got a value there, make that there, and I've got my query, and this does use that function-based index. But the problem is this currency conversion value, we're going to pass at runtime. You know, there's a whole stack of different values here. There's going to be at least one per currency. Good chance that they change, if not daily, they could change daily. You might even use spot rates. So basically, every time there's a new transaction, you could have a new exchange rate. Well, it's just not possible. It's not practical to create an index of all the possible different currency conversion values here. So, you know, we're kind of forced down this route where we need to use this function in our queries. So as we say, if we use a different exchange rate, because we've hard-coded it in the index, back down to a full table scan. So let's see what we can do to optimize this using PRAGMA UDF and the macro. Again, I'll start this running because it will take a little while. Literally all it's doing is just selecting, you know, fetching all the values, looping through them, doing nothing else. So we've got that function I saw before. I've also got the PRAGMA UDF version of it and a SQL macro version of it. So with our UDF, all that I've done here is add that PRAGMA to it. That's all that changed. With the macro, however, I've had to reorganize things a little bit because it is returning text, okay? And I've also had to convert that from a case statement to a case expression, or from an if statement, I should say, to a case expression. If statements don't exist in SQL language, so we need to turn this into something that is actually real SQL, because what's going to happen is the database is going to take this and essentially replace the where clause call, that function, the where clause, with this thing. I'll see in a second how that works. There we go. And just about timed that rightly to finish that execution. So we can see the pure PL/SQL function takes over 30 seconds to run. The UDF and the macro are both about 3 times faster. Okay, macro edging out user-defined function ever so slightly. So at this point, you might go, these two are similar performance. Why use the macro as opposed to the UDF? It's like, well, you know, if that PRAGMA gives you good enough performance, you can just stick with it. You don't need to rewrite things to a macro. However, macros do give you something that the user-defined functions don't, as I said. If we look at what's actually going on here, it's executing this function. If we look at the macro, we can see it's taken that expression to essentially put that in the SQL statement. So you can see we've got the flaw in here. What that means is the optimizer's got better visibility of what's going on here, increasing the chance it's going to get better row estimates and be able to use an index. Doesn't guarantee it, just improves the chance. Another thing is it might be able to spot some other types of optimizations. You know, if I do a currency conversion of 0, I did that if it's 0, always return 0 check. With the UDF, it's still a black box. The optimizer doesn't know that, doesn't know what's going on here. But because it's resolved that with the macro, and it's actually able to see, oh, okay, I'm returning 0, so I can check 0 is not equal to 2, and essentially optimize away the whole of this execution. Notice, last starts none, rows none, gets none. So in some cases, using this macro enables better optimizations because the optimizer's got better visibility of what's going on underneath the cover. One thing to do note, however, is that you cannot create function-based indexes on macros, right? It doesn't work. Why? Well, as I said, it returns the expression and the expression becomes part of the SQL statement. What you need to index is what it returns, okay? So, you know, in this situation, it doesn't help us here with this situation, but that was kind of the point here. Questions or comments on that? I know we're kind of getting on the hour, so and some of you probably got other meetings and stuff to rush off to. So I'll do the recap quite quickly, and then I've got time to hang around for questions if people want to know more about these things as we go on. Is macro backported to 19C? Yes and no, okay. Table macros only have been backported to 19C. Scalar macros are 21C only. Unless you're on an autonomous database, if you're lucky enough to be on autonomous database, the whole thing's being backported to 19C. So, but in general, scalar macros, you'll start to wait. All right, so PL/SQL functions in where clauses. Let's assume we actually need one. In order to make the function-based index, you must declare it as deterministic so the database knows it gets the same results. And you know, if you declare it deterministic and it's not deterministic, you're lying to the database. Unpredictable, weird things can happen. So don't do that, right? Okay. Okay, so maybe we can't create an index or the index isn't useful for whatever reason. How could we improve the performance still? Well, we can use this PRAGMA UDF, which can aid the performance of PL/SQL functions you use primarily in SQL, or we can declare it to be a scalar macro, which means at runtime, we are executing pure SQL or whatever that underlying expression actually is. Do note, as I was saying, scalar macros are 21C, table macros are 19C. Just recap all together, as I was saying, when it comes to functions in where clauses, the best solution overall is to just avoid them altogether and rearrange your where clauses to avoid them. However, that is not always possible for a whole bunch of reasons. If you are in those scenarios where you cannot just rearrange your SQL query to remove the function call, then look at creating function-based indexes or creating virtual columns and then indexing those. They actually are the same principle. It's just by defining the virtual column yourself, making it visible to end users and making it clearer what's going on, increase the discoverability of this. Finally, if you do need to use PL/SQL in your where clauses, you know, there's just no alternative here. Make sure you declare it deterministic. provided it is deterministic, of course, and consider looking at user-defined functions and scalar macros in 21C to optimize the performance when you cannot index those, or indexes turn out to not be useful for whatever reason. If you want to know more about SQL tuning, SQL performance in general, I've got my free class, Databases for Developers for Performance. Dive into all sorts of ins and outs of creating execution plans, creating indexes, how they work, that kind of thing. So completely free. Recommend you check that out. And if you want to know a bit more about function calls and where conditions, Danny Schneider wrote a blog post recently where he talked more about helping improve those cardinality estimates. That's something I touched on a little bit, but didn't go into a huge amount of details. So all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something. I'm Chris Saxon, and I hope to see you next time.